1609, even odd tree. So the question is, a binary tree is named even odd if it meets the following conditions. The root of the binary tree is at level index 0. Its children are at level index 1. Their children are level index 2, etc. For every even index level, all nodes at that level have to have odd integer values in the strictly increasing order from left to right. For every odd index value, all the nodes at the level have an even integer values, strictly decreasing order. Given the root of a binary tree, return true if the binary tree is even odd, otherwise return false. Okay. So input is root, which is a tree node. Obviously, the edge case is that it could be none. That's the most obvious edge case. We'll handle later. Output is just a boolean, true or false. The true is a valid binary tree, valid even odd tree, and false is a non-valid even odd tree. So what are the conditions for an even odd tree? So the root is at level 0. Odd values in strictly, okay, increasing at even at odd levels. So this will be 1, 3, 5, etc. Even values in strictly decreasing at even levels. So this will be 2, 4, 6, etc. Right. So strictly meaning it has to be I minus 1 has to be strictly less than I, right? There's no equal sign. Okay. So this immediately, how I personally would do it is I would go through every level and just check if it meets these conditions, right? So level 0, this includes odd levels. Sorry, at even levels. Odd values. At every even level, even level, all nodes at the level have an odd integer value. Okay. Aside from that small hiccup, so 0 should have odd value, so that's one thing. Root should have odd value. But I'll just do a breadth first search. The breadth first search allows us to go through every level and can verify in breadth first also allows us to go from left to right approach. So I think with that, is there any issues in inputs? No. Okay, so it is just a breadth first search. If at odd level, so we need to track. Things to track is current level and the previous value, right? So this will tell us. So we need to track current level and the previous value, and this will be used for tracking the if it's in the correct order. So if you add an odd level, it's being done by level mod 2 is equal to 1. We can initialize this as none. So if previous value, I'll take a none. Return if so at an odd level we need even values. So first we need to check even values. So first we need to create a queue with the root, and then while queue new queue, this, and then for every element in the queue, if at odd level, if value is none, element dot val mod 2 if is not equal to 0 or previous value, so at an odd level strictly increasing, so previous value needs to be less than element.val. So these two need to be true. If neither of these, if any one of these are not true, if this is not true, return false. And then if at even, if at even level, which is level mod 2 is equal to 0, if previous, oh, then we just, sorry, we just set previous val is equal to element.val, previous value not equal to none. If not, element.val mod 2 is equal to 1 and previous is greater than element.val, return false. And then we can just set this honestly at, not here, but just here. And then if that all passes, we just do q is equal to new q, return true. Okay, let's set this up. So q is equal to root while q for node in q. Oh, so we need to check level. If at odd level, so if level mod 2 is equal to 1, we can honestly, and actually I think just for readability it just helps me personally. If not, element.value, is it just val? Okay, mod 2 and previous less than element.val, no, sorry, not node, node.val, return false. Elif level 2 is equal to 0. If not, node.val mod 2 is equal to 1. Previous is greater than node.val, return false. And then we just need to do previous val is equal to element.val. And then one thing we need to do is set the previous is equal to none. And then level plus equals 1. And then q is equal to new q. Oh, and then, oh, shoot. If node is none, continue. What's that as children? So new q dot append node dot left, new q dot append dot right. Okay, if that's the case, return true. Okay, let's go have an example. So given this example right up here, so we have the root, our level 0, the new queue is empty, previous value is done for every node in queue, so that's just a root node. The node is not none, so we skip that part. and then the level is 0, so 0 mod 2 is 0. Um, so not have val, that's 1, and the previous is none. Oh, wait. Oh, wait. I guess logically. Previous val. Mod 2 is not equal to 1. We need to return false. And then we need to do this. Because we need to check previous val to none. And okay. I guess it's going to be combined as this. Just condensing this, so makes sense. So it's just simpler if statements. It needs to be in this order. Okay, so root. So it's here. No dot val of 1. So this is true. This is false. And this is equal to 1. False, or this is equal to true. So this is true. So this true and previous val. And then wait, so this becomes false. So this is immediately false. And then you add its children left and right. So 10 and 4. And then previous val becomes 1. But then that's all the notice is. So level becomes now 1. The cube becomes just now 10 and 4. We go back here. Previous val resets to none. For 10, notice on none, so continue. Level 1. So it becomes here, and then no.val. So this is 0, so this is false. And this is none, so this becomes false, and then skips, and then adds 3 and none. Right? 3 and none. And then the previous val. And then previous val becomes 10. And then it comes here. This is 0, this becomes false. I just throw this one in. This returns false. Returns false. All of it returns false. Shoot. No.val. 0, 1, 2 is 0. Okay. So this is the even route, right? Even. At odd, this is supposed to be 1 and 0. No, shoot. Mm-hmm. No, sorry. Previous file. Okay, it's at the right level. Oh, this should be equals. My goodness. So even. Wait, what? Oh. previous exclamation. Wait, this returned false. Wait, how is this failing? My gosh. Previous val is none. Node val is none. So this should be previous val. That is returning. Oh, wait, no, it should be, no, wait, it should be not equals. That's what I'm saying. Oh, wait, no, this is wrong. Because it shouldn't be 10. Wait, how is previous val not being? I don't understand why. Okay, I'm gonna end this recording and I'm just gonna debug on my own.